We're going to get started so we can stay on time. And I'm going to stand over here so I'm not in the sun. I should have brought my sunglasses. So I'm going to talk about automating dev in kind of the DevOps space. Kind of talk a little bit just generically about the problem space. Talk a little bit towards the end about our products and what we do, things like that. And feel free to ask questions as we go along. I'll try to leave a little bit of time towards the end for Q&A. Feel free to make it interactive if you do so. So, why are we here? Software apps are pretty much everywhere. 20 years ago, if you had told me that, the Gap was going to be a customer of my software company, I would have laughed at me. Unless I wrote AS400 software or ERP software or something like that, right? Much less, Family Search or all these others. So the stuff is everywhere. It's completely pervasive, right? It's in your car. It's in your in your pocket. It's where you bought most of the stuff you own, probably. At least if you spend as much time and money at Amazon as I do. So this is going to be a much more pervasive problem than it was back when it was just a bunch of ISVs and computer software vendors and those kinds of people running software. So the complexity is also increasing, right? Our apps are becoming more complicated. We're modularizing them. That simplifies things for developers. It doesn't necessarily simplify things when you kind of want to get it out there and deploy it. Everything is multi-tiered these days, right? The processes are becoming more complex, especially if you're at all in a regulated space, if you're in finance or healthcare or energy. You have to do a lot of things to prove that your stuff is audited and tracked, and that your separation of duties is being obeyed, and all of those kinds of things. So the processes are a lot more complex, and there's just a bazillion more tools out there than there used to be. Everybody has their favorite tool X for doing process Y, and different teams have chosen different tools to use. It'd be great if we can get everybody on the same tool set across the universe, if those were good tool sets, but that's not going to happen, right? You hire new people who bring in new expertise and bring something new to the table. You have an M&A or something like that happens, and so you bring in a whole new set of code that you have to work with for a whole lot of tools that come on in. Everyone's welcome. So what's the cost of not paying attention to this, right? If you're not dealing with this problem, right? Time to market is an issue. One of our customers, Family Search, when we started working with them, the time from code ready, out of development, tested, ready to be released live to the customer was 90 days. So 3 months to jump through all the hoops, not because it just sat there for 89 days, and then on the 90th day they were like, all right, let's deploy it. That was how long it took them to get through the process. Lots of manual processes, lots of sign-offs, lots of things, because they didn't want to get it wrong. The cost of screwing it up is very expensive. And so, in a pre-continuous delivery kind of universe, which I think we kind of still are in, the way that you approach that is you mitigate the risk and you do it less often, right? And that means you're going to have, even if you're an Agile software organization, you're building tons of features every 2 weeks or every 3 weeks for your customers. That doesn't do you a lot of economic good as a company if it then sits on the shelf for 90 days before your customers get to see it, right? So time to market is definitely an issue. App quality, all of the kind of error-prone manual processes that you go through to do a deployment, to do a release. As in the case of Equinix, 10 plus errors per cycle going through, right? Where somebody fat fingered something or forgot to do something, or I forgot that we added that new step that we need to do before we do that. All of those kinds of things. It's very labor intensive because once you've made a mistake, you've now got to figure out what was the mistake, how do I mitigate it, how do I undo it, how do I roll back, how do I deal with this problem? Very, very expensive. Process and application visibility in the case of a company like Lockheed Martin, where they have very, very strict audit requirements on all of their software. Who made changes to the software when, what was the tracking of that software, who signed off on it, how was it tested, all of these things. Would literally be, every single time they make changes, days and days and days towards the end of the cycle spent kind of coming up with those reports, with those audit reports. And kind of that's usually the bad time towards the end of the cycle to be doing those kinds of things. You know, you'd like to be thinking things, wrapping things up and putting a bow on it and all those kinds of things. But instead, you're kind of tracking down everything that you did, trying to figure out where everything went, because you have to. You know, not saying that's a good idea necessarily, but you have to. You know, just sort of overall development team productivity, right, and visibility. GE Energy was very aggressive about going agile. You know, they've really, you know, and they're a huge software company, right? These guys, GE as a whole, are, I think they said they're like the 6th or 7th largest software company in the world, right? If you count the amount of software that they write across all of their, you know, all of their companies. 20 days to troubleshoot problems. You know, this build isn't working. This test is failing. You know, this component isn't behaving the way we expect it to. 20 days on average to, you know, to notice, diagnose, and fix problems. Very, very expensive. So, you know, what do we need? You know, if we want to get to, you know, kind of the Jez Humble, you know, continuous delivery, application delivery, you know, nirvana that we all know is out there, you need to integrate the entire app delivery cycle. You know, and I realize, you know, I should sort of point out, you know, we always have these little graphs with, you know, you do this and then you do that, and that sort of looks very waterfall-y. You know, I just want to point out that it's, you know, these are all iterations, these are all, you know, this sort of all fits in with the agile way of looking at things. But the key thing being, you know, you kind of have to have something that's going to integrate the automation from end to end, right? From the time that a developer is done writing a piece of code, all the way through to when it's live in production and your customers are using it, right? Ideally, that's, you know, ideally you want that to be as short a time as possible, you know, and you want to be able to kind of manage all of the processes, manage all of the tasks as you go through that whole cycle from, you know, dev, QA, pre-production to production, and integrate. You know, this is where, you know, it gets a little bit relevant to why we're all here, why you're all here, which is integrate this to the infrastructure automation, because that's a big piece of what you need to do. Anytime I need to go do something in my process, whether it's run a build, run a test, do a trial deployment, you know, do a rollback, do a deploy, you know, a schema upgrade, do anything that you do, you're doing it on top of something, right? You're doing this on top of some sort of infrastructure. And so you've got, you know, and, you know, I call this typical software delivery process. That's typical is probably a bad word. This is just a sample software delivery process, just for the sake of discussion. But, you know, Dev has their process. You know, we have an SCM system, that check coding, that triggers a build. You know, if you're doing system testing as part of your continuous, you know, build and test process, you may even do a deployment and do some dev testing on top of that. You know, you may be doing unit testing, you may be doing all kinds of stuff in there. Once you get into more of a QA mode, and again, you know, if you're doing Agile, this picture may have a different shape, but all of the boxes still exist, right? They may just be arranged slightly differently. Again, you can do some functional testing, perf testing, load testing. You know, you may do regression or acceptance testing as part of a release team or as part of a QA team. You know, these, again, the boxes kind of move. You got to consolidate, analyze all of those results, and then, you know, as you get later and later into and closer to where this thing's going to go live, you deploy it and you need to manage the app. You know, all of these things, it would be nice if they weren't as siloed as they are today. Right? Dev has their process, QA has their process, release teams have their process, ops has their process, and nobody talks the same language. Right? And you're not going to get to continuous delivery unless you overcome those boundaries. So the other thing too, and, you know, this is where I think the infrastructure and the deployment kind of message that comes in here is, you know, you do many deployments per release cycle, right? It's not just one deployment to ops, right? That's not deployment, right? I'm an engineer, I write code, I do probably 20 deployments every single day. You know, it might be a hot swap deployment into a Java VM because I changed the class file, or it might be that I, you know, tear down a Tomcat instance and restart it and replace all of the, you know, all of the classes. But I'm doing deployments, you know, and similarly, if I'm doing any sort of QA or any sort of system level testing, there's deployment happening, right? So I think one of the messages that we're trying to get out there and kind of evangelize a little bit is start with consistency, right? You're doing many more deploys in QA and dev than you will ever do in operations. Why do them completely differently than you do in operations, right? Why have ops be the first time you do a deployment a particular way, right? We can do better than that. And by getting to the point where we've done the same process repeatedly over and over, granted to different environments with different constraints and maybe even missing pieces as we go along, but you're going to get better and better and better at doing something. You know, Well, the only way that we get better at doing something is to do it often, right? And if you're only doing deployments every 90 days to ops, you're not going to be good at it. It's going to be the first time every time. All of those kinds of things that we talk about in the ops space. So, and again, we need infrastructure to do all of these things, right? I need boxes to be able to run tests on. I need boxes to be able to build on. And when I say boxes, I of course mean a box that may not have existed 5 minutes before I needed it, right? Virtualized in the cloud, maybe in your private cloud, public cloud, hybrid cloud, whatever kind of cloud we've invented today to try to get a little edge in the market. All of those things require infrastructure, right? And that infrastructure either has to get set up, or it has to get cleaned up, or it has to get torn down, or it has to get managed, right? One of the biggest problems we see, with our customers is when they go to virtualized infrastructure is they have VM sprawl, right? Now all of a sudden, you used to have a fixed number of assets, right? I had 50 racked up servers, that's all we got. I'm going to put a post-it note on every single one of them and see what it's doing. Well, guess what? When you go to a virtualized infrastructure, forget the post-it notes, right? You're going to have 1,100 VMs before you know it, and you have no idea who's using which one for what and when. Can I tear this one down? Why is this one using so much disk space? Why is this one using so much CPU? Who's behind this, right? So you need to manage all of that infrastructure. You need to know, why was this VM deployed? What deployed it? What was it used for? Is it still being used for that? Or was that process, moved on to something else? So the notion of going from raw metal, whether that be raw physical metal or raw virtual metal, to something that you can use and then maybe tear it down or reuse it is that's a very interesting thing. It leads to very much more effective use of the resources that you have. And the days, luckily with virtualization, the days of running around and trying to find a boot floppy so that I can get the CD-ROM working, so that I can, get the driver up, so I can pixie this machine, so I can, oh wait, I'm not supposed to use that when you're still using it. Those days are mostly gone, but at the cost of the sort of VM sprawl and proliferation, which eventually leads to, hey, we run out of disk space. We need to buy $60,000 worth, of disk space now, or more VMware licenses, or more Hyper-V licenses. All of those things. So you're kind of back in the same problem that you were before, only now you got more of it than manage. So of course, infrastructure management is key to this, and especially the kind of infrastructure management where you can just bring things up when you need them and then throw them away. Right? If you're going to run an hour-long process, then if it takes you a minute up front and a minute on the back end to bring something up that didn't exist before and then tear it down afterwards, assuming you don't need it, that disappears into the noise, and the benefit is huge. Right? The benefit is huge. You know that thing is configured exactly the way you want it. Nobody's touched that thing before. Right? That image, that system is exactly the way you asked for it to be. Nobody's logged in and installed an update. Nobody's installed their favorite browser. Nobody's screwed with the system DLLs. All of those kinds of things. It is what you need it to be. Right? So that's key kind of across everywhere. And I think one of the key points here is not just knobs. Right? And I think a lot of times when we kind of talk about in the sort of puppet and the chef world and those kinds of things, of course sysadmin tends to be, and ops tends to be a big player in it. But guess what? It's everywhere else as well. Right? If you're doing it right, because you're always having to set up and tear down and manage the infrastructure for all of these other kind of silos as well. And why do that differently for one silo than you would for the next one? Right? The needs are very close to each other. And there's really no reason to do that. So if we think a little bit, kind of look at, peek into these silos a little bit, and this is oversimplified, and it's going to be different for every single team, and it's wrong for your team, and all of those kinds of things. So this is just a, sort of a sample stack, right? You've got some core infrastructure that you need, and I'll just sort of, I'll cheat and tell you the core infrastructure is the same for all stacks. Right? I mean, you've got your OS packages, patches, you've got some sort of infrastructure, base infrastructure that you're running on, whether it be physical or virtual, some sort of fabric that you build all of this on top of. You've got build tools that need to be installed, you've got build tools that need to be configured, and then you need to run build and say unit tests. Right? And you need to do that often, because we're agile, right? And cycle times matter. If you have a 6-hour build and test cycle for doing this kind of stuff, you're going to have a tough time being an agile shop, right? Because the time from when you check something in to when you get the feedback is too long. So you need to get those cycle times down. So you need to manage those things. And that isn't always like, well, shoot, we have a 6-hour build and a 1-hour unit test. It's much more likely to have a pretty fast build, and you have lots of testing going on. And you might want to manage those tests and be more agile about the way you do those things. Maybe for your continuous processes, figure out what the true smoke test is. Figure out what the subset is that you can run, and then have different cycles that run at different intervals. Right? All of those kinds of things. But again, there is infrastructure to be managed, and there's infrastructure to be kind of installed on top of that as well. The test stack, again, the infrastructure part looks a little bit the same, but we get a lot more. We're probably going to have some sort of middleware, right, or some app servers, or something that the test team, or the QA team, or the release team, or the integration team, or whatever the name of the team is, that they use and rely on to be available to them, kind of separate from whatever the app is that we're testing, right? Then we've got to deploy this, multi-tier beast. We've got to configure it. We've got to set up some sort of test. We've got to run that test, and we've got to analyze the output and figure that out, right? And do that again as quickly and as easily as possible, right? And ideally, if I'm an engineer and and you're a QA person, and you found a test in you found a test that breaks in my code. Ideally, I can go make a fix and then just on demand run this test stack, right? I say, just run this test for me, right? Go configure all of this stuff, run it, and then tell me what the result was and come back, and do that in 5 minutes, right? That shouldn't have to be, I check in what I think is a fix for the problem. A few hours later, that spits out a build. That build then sits on the shelf for 3 or 4 weeks until we get to the part where we run the next, kind of scheduled test run when we find out, oh, I didn't fix the bug after all, right? I mean, that would be a little bit like if we were building cars, we put the instrument panel into the car and we park it in the corner of the factory for 4 weeks until somebody goes and makes sure that all the lights are working, right? If you build cars that way, you'll go out of business. Well, guess what? If you build software that way, your competitors are going to get the better of you, right? That has to be much more of a self-service kind of way. Similar if you turn it. If I found a bug, and I'm a QA person, and I notice that somebody marked that bug fixed, I want to be able to pull those bits, get them configured into my stack, even if there's no official build, even if, I want feedback as soon as possible, right? You want things to fail fast. And the only way that you can do that is to automate things. Automate the infrastructure, automate the provisioning of all of these things, automate the analysis and the output, and make all of these things more self-service. Once you get into production, again, the infrastructure part of it, lots of it looks the same, and we're going to deploy and configure our multi-tier application. And maybe in this particular scenario, the acceptance tests are run on a pre-production environment, let's say, and then we throw it into production, kind of transition officially to ops or to monitoring or to kind of whatever you want to call it. But the point being, by the time we get to here, we've done dozens of deployments. Right? We've done dozens of infrastructure setups. We've done dozens of deployments of the app and configurations and all of those things. Why should this be different than all the other ones that we did up to now? Right? That's part of kind of a little bit of the message we're trying to evangelize with our products in the kind of the DevOps space. So you need something that's going to manage this, right? What version is installed where? What environments are available to me? What's the status of this release? What's the status of this environment? What's installed in this environment? Can I use it for this kind of testing? Or is there enough capacity in my VM infrastructure to set up another test stack? And if not, what do I do about that? Do I scan things? Do I refine other things? You need something that's kind of going to give you the dashboard for the overall thing. And this is where I could sort of switch over to commercial mode a little bit. Electric Commander is kind of the integrated DevOps process management tool that we sell. And so it's an execution environment, a monitoring environment, not monitoring in the sense of like, back-end monitoring kind of stuff, but for your processes. To set up your workflows, to set up here's my build test workflow, here's my release workflow, here's my pre-prod workflow. And manage not just a single build, but many builds or many test processes or many different configurations through that. Through those processes, and kind of handle the integration to all of the tools that you use, to all of the infrastructure, type environments that you run in, and all of those kinds of things to handle that. Also, we have Electric Deploy, which is really kind of we're calling next generation deployment. There's a few things that we've done in here that we think are kind of differentiating and unique and interesting. It's model-driven. That's not necessarily so unique or differentiating. But one of the key things that we've done is we've separated out the application model from the environment model. And that gets back to this notion of why do you want to do a completely separate deployment just because you're deploying for a test as opposed to deploying to ops? What really changes there is that the deployment itself, it's the environment that you're deploying to, right? When you're deploying to test, you may have a load balancer, maybe you don't. You may not have a firewall that you need to configure. When you go into the ops arena, yeah, you do have a firewall, you do have a load balancer and all those things. If I'm a developer and I just need to deploy something so I can run some system tests on it, I probably don't care about the load balancer. I probably don't care about that. But almost everything else in that application model is the same. You know? And after all, the application model largely comes out of development. Right? I mean, it is the application developers who determine what the application model will look like. And to have no notion across the silos, dev, QA, release, and ops, of what that model is and how it's evolving, and how is it different in this version than it was in the last version. Right? Oh look, a messaging component just showed up. We didn't have that before. What do you app guys think that we're going to run in ops in order to do this scalably? We're going to use ActiveMQ, or we're going to use RabbitMQ. What are the options that we can go with there? And have that conversation, early on in the process, not the week before you're about to go live, right? And kind of have a common UI and a common framework for working through those, where the app model is the same. Okay? It's the environments that you're deploying into. If I'm deploying into a single node environment because I'm a developer doing some testing, most of the DNA is the same. If I'm deploying into a 4 or 5 node test cluster to do some scalability testing or regression testing, again, the DNA of that deployment is very much similar to what I did before in the development stage, and so on all the way to ops. And just because I'm going to 1,500 web servers when I deploy to live production, and I was only going to 50 in pre-prod or 5 in pre-prod, that doesn't mean that the process is any different. Right? So the other thing that we think is kind of interesting and unique is what we're calling Failsafe. And we have some features around that I'll kind of go into. And Failsafe doesn't necessarily mean no failures. In fact, it explicitly doesn't mean no failures. It means mitigate and minimize failures and help you work through them, right? And as my favorite show of all time, Mythbusters, is they always say failure is always an option, right? Something will go wrong, right? What do you do when something goes wrong, right? If you have your 527-row Excel spreadsheet, which is your deployment plan, which that's an actual example from a customer. Well, if you get down to 413, all right, go back. When you're sort of like Sheldon in Big Bang Theory, when he's doing all the elements as he runs down the stairs and he gets one wrong, he has to go all the way up to the top and start over again, right? That's crazy. So the idea is, provide some functionality and features for runtime troubleshooting, and being able to develop this process, right? And now, through Puppet and all of these tools, we've got great tools for developing the atoms, for pushing out this particular image, for pushing out this particular product, for moving these bits from here to there, and all of those kinds of things. But you also need to orchestrate that across a complex environment, and orchestrate and kind of manage it across across time, across space, across teams, all of those kinds of things. And things will go wrong at that point. And as well as another piece of this is sort of the ability to define success and failure thresholds. If I am deploying 1,500 web servers and 10 of them don't come back up, is that a failure? Do I roll back because of that? Probably not. I probably say, no, I'm fine at a degraded capacity of 1,490 with 10 that blew up for some reason. Maybe the power supplies went bad, or something else went bad. But I'm going to roll forward. Right? Rolling back for those kinds of things is not necessarily what you want to do. Again, you have the ability to define those kinds of things. And again, depending on the environment that you're deploying to, that's environment dependent. If I'm deploying into a 2-node cluster to do some testing, if one of those nodes doesn't come back up, that's failure. Right? That's not acceptable. If I'm deploying into a multi-hundred node cluster, if 1 or 2 don't come back up, that's probably not failure. It's probably okay to keep going, circle back and do a partial deployment to the failed node once you figure out what went wrong. And again, be able to sort of recover from failures, figure out what happened, do root cause analysis from one place instead of shit, where does that log file end up? Something went wrong, but what? All I have is an exit code. Error 150. What does that mean? Where did that happen? And how soon do I notice that? Do I have real-time reporting and analytics as these things are happening in my complex deployment? Or do I wait until the end and then grep through my half a gigabyte log file? Friends don't let friends grep through log files. That's just not what humans ought to do. Let the tools do that for you. So we've got functionality around being able to set breakpoints during your deployment. So I want to skip certain pieces. I want to put a breakpoint here, and to be able to iterate on your development of this process, right? Because you need to develop this process the same way that you develop your code, right? And the same way that if you're going from bare metal to configured applications, you want that to sort of live next to your source code so that you can version it. You have the same issue with your deployment process. Once you take all of those pieces and orchestrate them together and coordinate them through doing a deployment, again, no matter what the target environment is, you want to be able to debug that. And you don't want to have to debug that by putting sleep 600 in your script and then running down into the data center, logging into the machine, and oh shit, I only have 30 seconds left to figure out what went wrong. Right? That's So we're trying to I wouldn't claim that this is an IDE for deployment, kind of development, but it's it's kind of getting us there a little bit in terms of being able to stop, inspect the environment, maybe even make changes to it, right? And of course, the fact that you're debugging and making all these changes and so on will sort of will taint this deployment process that you're working on. So it's not something that you can necessarily push through your pipeline. You have to snapshot it and test it and all of those things afterwards. And again, a little bit of just this notion of what is failure. This is a very simple example of look, how many of the hosts, in this case in our simple little HSQL DB environment here, how many hosts am I going to tolerate failures on for this particular phase of the deployment, by percentage or those kinds of things. And you can do much more, kind of complex behaviors in terms of doing analytics and doing testing and those kinds of things as part of bringing things up. So I'll sort of wrap it up here a little bit and leave hopefully a little bit of time for the Q&A. Yeah, pretty good. Benefits of this kind of automation and end-to-end integration of all of these tools. Reduced delays, faster time to market, less errors and higher quality. When you do have errors, hopefully they're happening during the development process of your deployment processes, not during your go to live or go to pre-prod type arena. And again, why use a different process for every single silo that you have? Use the same one, deploying to different environments, and get good at it. Right? Get good at detecting failures. Because I guarantee you that you'll get more failures during the development, right, that you have to account for, that you don't want to have happen when you go to your pre-prod, and all of a sudden you decide, well, guess what, we're not going live tomorrow, we just found a problem. Improve collaboration, because at some point, all of the kind of silos across all of the different organizations who report up through different structures in the corporate hierarchy and have different things that they're measured on. Ops is typically measured on uptime. Well, how do I guarantee uptime? Don't make changes. Well, what does development do? They're paid to make changes. So, how do we get those two things to work together and be better? Well, let's start with an application model that we can all agree on and share and use and track. And let's start with deployment processes and infrastructure processes that we can all use and share. And yeah, we're deploying into very different environments with very different costs of failure. But that's all the more reason to do it kind of the same and not different things. Reduce cost, improve utilization, motherhood at the pie, all of those things. And returning to the kind of to the what's the cost of not doing something about this? From develop to deploy, family search is now in a 10-minute cycle. Right? They are outside of the giants out there, the Googles and so on, they are the smallest organization that I've worked with that truly is going continuous delivery, right? Literally to the point where, yes, Mr. Customer, yes, we have that bug, we're working on it, let me give you a call back in 10 minutes. Okay, try it now. Oh, it's fixed, great, right? That's very different than, yeah, we fixed the bug yesterday, but it's going to be until, end of November before the customer sees the fix. Dramatically different experience. Getting down to where there are no errors in the cycle. And by errors, I sort of mean human errors, right? You're still going to have failures, right? You're still going to have machines that go out, power systems that go out, disks that flake, networks, and all of those kinds of things. But to get to the point where you sort of push the button and it goes all the way through, because you're not sitting there with 18 PuTTY windows open, you know, okay, now I gotta type this in here, now I gotta type this in here, now I gotta reboot that. Oh shit, I rebooted the wrong machine. Right? Those kinds of errors you want to eliminate and get rid of. Track all of the changes that you're making as you make them instead of spending all the time at the end of your release trying to come up with them. And you know, work with systems, work with tools that help you figure out when things go wrong. You know, but a tool that just says exit code 1 is not a tool, right? That's not useful. What you need is something that when something goes wrong tells you that something went wrong, where and why it thinks that went wrong, and lets you drill in on the root cause and do that. So that you might be, you might have a 2-hour window to do your deployment in, and it takes you 30 minutes to do the deployment, right? You don't want to find out after 30 minutes that something went wrong 5 minutes into it, right? You want to know right at the 5-minute mark when something did go wrong, so that you can decide what to do, right? Decide to push through, decide to patch it up later, decide to roll back, and not lose those 25 minutes of not having that knowledge. So that real-time information flow is really critical, and that's stuff that you get on Commander and Electric Deploy. And then a little plug for our summit later next month. Come on down. It's a nice place. We have fun. And that's all I have. So I'll take questions, and then you get the ice cream. Last year I talked right before the bar opened. That was a little harder. If there's no questions, that's fine too. Well, I'll stick around for a few minutes if you guys just want to chat as well. Otherwise, ice cream road.